so let's look at the intensity at these two different points. So from, I1 is again what? The power, power in, power of wave, right? Sound wave per area. What is the area here in this sphere? So, if you have a sphere here of some radius r, surface area, this area means surface area, okay? A is what? 4 pi r square, okay? So P must be equal to 4 pi r1 square. Similarly, we can write I2, which should be equal to P over 4 pi r2 square, okay? So now, next step, I'm going to erase this, okay? Now, if we take the ratio of I1 by I2, what should we get? See these guys, right? This part is constant, this part here. So one divided by another, they will get cancelled. But then these have the inverse relation here, okay? So we get I1 by I2, I1 is 1 over R1 square, divided by 1 over R2 square. That will end up giving me this, sorry, R2 by R1. I can write this whole as a square, okay? So this is the ratio of the intensities at two different distances, R1 and R2, okay? So we can say as the distance increases from the source, the intensity diminishes, okay? And then it's not just linear, but it goes by square, okay? So this is important part. This part here, this really, okay, I'm gonna write down here, up here. The intensity is goes like this. Intensity is proportional to 1 over r squared. Do you guys see this part is, if you know? So this intensity proportional to 1 over r squared, this is called inverse square law. Does this look familiar to you guys? Inverse square law? I hope it does, because you guys learned about Newton's law, right? Newton's gravitational law. It's the similar concept here, inverse square law, okay? Alright, so that's about sound intensity. Okay, so this is the sound intensity, but when we talk about, the loud, like the noises we hear, we measure that loudness in terms of something, in terms of a quantity called loudness of sound level, okay? Or intensity level, really, loudness of sound is measured by intensity level, not intensity. This is important. Level, okay? So this intensity level is not I that we just learned, okay? So loudness of sound is measured by intensity level. Really, it's called sound intensity level and represented by quantity sound intensity level, represented by quantity beta. This is a lowercase Greek lowercase beta, and it is called beta, okay? So I'm gonna just write here, oops, not beta, it's called beta, okay? So sound intensity level. Okay, so alright, so we talk about the sound, we talk about the speed of the sound, we also talk about sound intensity, but then when we talk about the loudness, we don't talk about the intensity. So but we talk about the sound intensity level beta. This is a different quantity here. So let's say we have a speaker, it's producing some sound, and then we amplify that and then intensify that, okay? If we change the intensity by really greater amount, but then the loudness we hear is not the loudness we hear is not same as the amount of intensity we increased, okay? So let's see, then how are we to talk about the sound intensity level? Okay, so there is something called threshold of hearing. This is sound intensity and represented by quantity I naught, okay? So this threshold of hearing I naught turns out to be 1 into 10 to the power minus 12 watt per meter square, okay? So threshold of hearing is really, it's like, okay, that's the zero scale. Not the value is not the zero, but that's like the reference point, okay? So okay, now we have something called threshold of hearing, and whatever the loudness we want to measure, now we will make a measurement with respect to this value. So this is like our 1 point, and then like this is like this. It's like here, if you want to measure a distance, you need the zero level, right? And then you can talk about 1 meter, 2 meter, 3 meter, right? Same idea. In terms of intensity, in terms of sound hearing, we first of all we need to define, we need to have a reference point, a reference reference intensity, and that's called threshold of hearing, okay? So this is I naught equal to 10 to the power minus 12 watt per meter square. Once we have this, we can define this sound intensity level quantity beta, as this beta is given as 10 log I naught by I, okay? So guys, see this here, important thing to notice, this is a log base 10, okay? This is not the natural logarithm, this is the log with the base 10. So whenever you do calculation in your calculator, make sure you use the LOG, or make sure you use the log with the base 10, okay? Not the natural log ln, no, not that, that's the natural logarithm, okay? So beta equal to 10 log I naught by I, where I is the intensity at some, other distance. I naught is the threshold of hearing, okay? And this quantity beta will give us the sound intensity level, or the loudness of the sound, okay? What do you think is the unit here, guys? Do you think this quantity has any unit? Beta 10 does not have unit. It's a dimensionless log, dimensionless I naught divided by I. The unit gets cancelled, so beta is a dimensionless quantity, okay? So it does not have a unit. Okay, so let's do a example. Let's do examples for sound intensity. So a small source emits sound wave symmetrically in all directions. The output power of the source is 80 watt. Okay. A. Find the intensity of the sound 3 meters from the source. B. At what distance would the intensity be 1/4 as much as in A. Alright guys, so here very important step doing problem in physics is what? Write down all the information, draw a figure, right? Draw a diagram. So I'm going to leave this here, but maybe let's move it a little bit further away. So here, a source, right? Emits sound waves symmetrical in all directions. So let's say we have our source is like this, right? And it emits sound in all directions. So we can just draw. Let me make better sphere, guys. This looks like potato here. Okay. Let me draw a physicist circle, okay? Okay, how about this? I draw the circle first. That's better. And then put a dot. That way I can put the dot where I want, right? So, this is the source. It emits the sound symmetrically in all directions. The output power of the source, so power P is 80 watt, okay? So we are given here P equal to 80 watt. Find the intensity of the sound 3 meters from the source. So R1, let us call this as R1 equal to 3 meter, okay? Or you can just call R really. I'm just calling it R1 because I know we have to do something there in number B also. That's why I'm giving it 1 and 2 label. Okay, so we are given R1 equal to 3 meter, okay? So please find what should be the intensity I1, right? Since it's I'm calling this as 0.1, I1 at this distance, okay? So please take a few minutes and then work out on this problem. And if you finish this one, please go to number B, okay? Oh, B also, I'll write the question for you guys here, B also. So B says, at what distance, let's call R2, that distance what, would the intensity be 1/4 as much as in A? So I2 has to be 1/4 as much as in A. In A we have I1, okay? So all I'm doing is just writing down, and this value, so that's the condition we are given, okay? Alright guys, please take some time to work on this problem. Okay guys, so did you guys get it? What value did you guys get? So let us see. So I'm going to take this away. Alright. So A1, right? So for this problem here, we already know what intensity I is what? I1 must be equal to what? P per A1, right? Area. So which is what? Power we are given. P is 80 watt. So 80 watt divided by area is 4 pi. R1 is pi. In place of R1 we are given 3 meter. So this, right? So what do you get here? So did you guys get 0.707 watt per meter square? So which is about 0.71 watt per meter square. Okay. So for